So welcome to everyone who's here. We'll start in 30 seconds, I guess. Another minute here for people who might be coming in. Okay, 6 o'clock. So welcome to this session on spillovers classroom to research to student growth. And I'm very excited to hear from our two speakers this evening. First, we have Maila Hallare. Is that kind of right?
Hallare.
Hallare, okay. From Norfolk State University, who's going to share with us about strengthening the research teaching nexus via partnerships and collaborations. And this will be a 25-minute talk, and then we'll take a 5-minute break for transition. And yeah, we're just glad to have you all here. So take it away, Maila.
Thank you, Tova. Again, there is a slight change in my presentation. The new title is Strengthening the Research Teaching Nexus via Partnerships and Collaborations. I also would like to put a new subtitle. I think I may have some tips for new mathematics professors out there. My name is Maila Hallare. I'm from the Department of Mathematics, Norfolk State University. Before I started exploring Nexus, and I've been using it as my Wordle starter. And yesterday's Wordle was humor. Today's Wordle is pause. So Nexus, I think, is a great way to, well, spoiler alert, today's Wordle word is pause. Anyway, so my main question was, will conducting research help me become a better mathematics professor? I would like to investigate this question as a faculty in an undergraduate institution. In particular, I am a faculty of a historically Black university in Southeast Virginia. We are mid-sized. We have about 5,000 students, and adapting a broadened view of mathematics research that includes creating undergraduate teaching resources that are, number one, interesting to the 21st century student. Number two, not in your usual textbook, in other words, unique. Number three, classroom tested and refined. I think the answer to my question is yes. Moreover, the Nexus achieves a full circle when our students become involved in undergraduate mathematics research projects themselves by further investigating and broadening our creations. Okay, I think you would agree with me that to investigate this question, I would need to put out some information, in particular, institutional context. Norfolk State University, unfortunately, does not have great graduation rates. What you see on the screen on the left-hand side is the most recent data that I could find in our website. Less than 40% in graduation rate. In fall 2013, our retention rates are a little bit better. 74% for the freshman to sophomore retention rates. This would be about those students who decided to come back for a second year once they have experienced their first year at Norfolk State. I also would like to complete the story by telling you about my usual teaching load at Norfolk State. So this was my actual teaching load in last semester when we came back after the pandemic. So here you see I have 14 units of teaching load, and 4 units calculus, 4 units developmental math, 3 units college algebra, and 3 units contemporary mathematics. Contemporary mathematics is our terminal math course for the non-STEM majors. So roughly, I have about 100 students every semester. There was one year actually when I was teaching 18 units, 18 units in the fall semester and 17 units in the spring semester. Anyway, to investigate my question, of course, there should be some sort of rubric. And I would like to share with you from our NSU faculty handbook, this academic portfolio faculty evaluation. And as I have highlighted here, we are graded on the following: 50% on teaching, 25% on scholarly contribution, and I'm sure you would guess that the other 25% will be from service. I did not want to clutter my slides too much, but this is just a listing of some of the requirements regarding teaching. 7 actually out of 14 requirements from us as professors, as teachers. And then regarding scholarly contribution, I highlighted 2 of them. Number 1 is faculty research, publishing papers in journals and conference proceedings within the teaching field or area of specialization. Part of that is supervising undergraduate research project. And so I recently submitted my portfolio like a couple of days ago. I haven't received my portfolio back, but I think I did quite well last year. So as I full disclosure, I only started preparing my slides just a couple of days ago. But when I submitted my abstract to the Simayodi Expo, I started mentioning about the research teaching nexus, this great connection between these 2 aspects of our job as mathematics professors. It turned out, and I was very pleasantly surprised, that there are already research teaching nexus models. So these models were created by researchers in education. And so I learned a lot. For example, one of the first research teaching nexus model that was presented was by Healy. It was published in 2005. So basically in Healy's model, we are looking at this 4 quadrants in 2 dimensions, where in the upper part is about the student as a participant. The lower part is the student as an audience. The right-hand side is about emphasis on the research process, and on the other side is emphasis on the research product. So for example, for our students who complete undergraduate research capstone projects, for example, in this model, that would be on the upper left-hand side where it says research tutored. Okay, and so a year after this model was published, there was another model which expounded upon that previous model by Healy. This was the model created by Wuderick and Turner in 2006. Unlike the previous model, this time the model starts with a 1-dimensional figure. Okay, so it's like a spectrum wherein on the left-hand side, we have teacher focused, and on the right-hand side, student focused. Conceptual change on the right-hand side, transmission on the left-hand side. I like this particular model because when I was reading this, I was able to relate a little bit more closely to this model than the other one, basically because I am trained in mathematics, not in education. So anyway, if you look at the 3rd interval from the left, it says there, students engage with outcomes, okay? And from that interval, you see that there are 2 arrows down there, what it says class activity coming out of research and inquiry-based learning. I would like to highlight those 2 parts because these are the so-called deliverables from the research teaching nexus. And I appreciate that these 2 things were highlighted in this 2nd model because these were some of the things that I learned a lot from. Okay, so also when you look at the 4th interval where it says students as researchers, the 2 products there were projects, dissertations, publication. So I think you can see that the 4th interval in this model actually corresponds or directly maps to the upper left-hand quadrant of the previous model. So if it is okay, maybe let me go back to the previous slide. So again, on the previous slide, we have there the student as a participant in the research teaching nexus, an emphasis on product of research. And so that upper left quadrant corresponds to the right-hand side of, or the rightmost interval of this one-dimensional continuum. Okay, and so I continued my research, learning more about these results from educators. And in the end, I was able to find another one. And I think this is the most recent one published by the experts. This one focuses more on the knowledge instead of the students. So here, let me just talk briefly about this model. This is by a Dutch educator, VC Win. And here, unlike in Healy's model, notice that there's more emphasis on the knowledge. Instead of looking at student as a participant or as an audience, on the upper part, we have knowledge production and knowledge transmission. And so when I read these description closely for each of the 6 variants, right? Because now we have the 6 rectangles there. I realized that it would help if I emphasize some keywords for each row. Okay, so let's look at the first row. Okay, so the first row is about production of knowledge. The second row, reproduction of knowledge. And then the third row is about transmission of knowledge. So I couldn't find, honestly, some research teaching Nexus from a mathematics professor's point of view. So I had to dig into the definitions of the creator of this model so that what he's saying will make a little bit more sense to me as a math professor. But basically, in terms of, let's start from the bottom, in terms of knowledge transmission of, say, the research process. Okay, so I am looking at this lower right-hand side. The knowledge transmission of research process, that would include when a mathematics professor will design some initiatives wherein the students will be engaged in some data fitting or parameter estimation, because data fitting and parameter estimation are essential processes in modeling. Let's now look at the second row. For the second row, I would like to highlight that this would be when mathematics professors do some activities involving inquiry-based learning, because once we, in particular, this row here that says knowledge reproduction based on research processes, that would be when learning takes place through a well-structured method, and then based on research processes. And so, for example, when, and this gave me confidence actually to do some inquiry-based learning. So because we have a well-structured method designed based on a research process that I have done myself. So when I go into the classroom, then I can deliver it as an inquiry-based activity, for example. And then finally, for the top row, let me just highlight that knowledge production. I think this would be the part wherein the students are directly involved with the research process. Now, having shared these 3 research teaching Nexus models, I couldn't relate directly because it doesn't feel like a mathematics research teaching Nexus experience. And so now I would like to humbly share my own. And it all started about 2 years ago when I was involved as a co-PI of this NSF-funded grant called Summit P. It is a national consortium for synergistic undergraduate mathematics via multi-institutional interdisciplinary teaching partnerships. The 2 keywords here are multi-institutional. There are 12 universities in this consortium. Now there are only 11. And so amongst ourselves, we have regular meetings. And also before the pandemic, the VCU, Virginia Commonwealth University members of this consortium visited us. We call it a site visit. And then regarding the teaching partnership, in particular, interdisciplinary teaching partnership at NSU, we developed this partnership with the Department of Engineering. So it has to be that the math department should partner with another department in the university in order to create more knowledge, basically. So at NSU, one of our goals was to help our students become more successful in their future engineering major courses. And so one of our activities was the so-called fishbowl activity. And it was really fun because the engineering faculty were discussing amongst themselves their wish list regarding their students' mathematics knowledge. And then we call it a fishbowl activity because the engineering faculty were like the fish, and we are the outside faculty observing and listening from their conversations. And I just want to share that from the engineering faculty's perspective, they would like our students in mathematics, or they would like the engineering students to be very strong in trigonometric functions and conic sections. And we were surprised to learn that because we were expecting that the engineering faculty would request, sophisticated mathematics methods from calculus 2 or calculus 3. No, they were requesting something a lot simpler than that. Okay, anyway, so that was a big component of my research teaching Nexus experience. The second big component is my involvement with Simayodi. In particular, I became a DMARC Fellow, Differential Equations Model and Resource Creators last year during the pandemic. And I think this is one of the best professional decisions that I have made in my life. Why? Because I felt valued as a mathematics professor and researcher. Because of my heavy teaching load, I know that I couldn't produce or be engaged in research in the same way that I was involved in when I was in grad school. More about that later. So that was the second big component. Now, after creating all of those teaching resources through the Simayodi DMARC, it is time to test drive my creations. So what you see here is an actual picture of my students in a differential equations class right before the pandemic, and they are looking at data generated from an online circuit simulator. Finally, and currently, the fourth big component of my research teaching Nexus experience is that I am currently a CURM Fellow, Center for Undergraduate Research in Mathematics. And as a CURM Fellow, we were able to receive some financial support in order to establish some research groups consisting of undergraduate students from CNU, Christopher Newport University, that's the captains, and from NSU, Norfolk State University, the Spartans. Okay, more about that. Well, I mentioned that Simayodi was one of the best professional decisions I've made so far. And what you see here are some of the Simayodi products that I was able to contribute last year, 2021. The top three and the lower left, we were able to complete that with, I was able to complete that with my friend and collaborator, Dr. Yordanka Panayotova. She is so amazing. And the second row, middle part, is a project that I created with a former classmate of mine in grad school. And then in a few weeks, Dr. Panayotova and I plan to submit another Simayodi project. Okay, and as you can see, I've been quite productive through Simayodi. Now, of course, this is the reason why I had to change the title in my talk. I couldn't do all of these without the help of many friends. This is Dr. Musavizade. He is the PI of the grant. And these are my 3 engineering collaborators. I learned a lot from them. Although I only published 1 engineering application in Simayodi, I have publications somewhere else. Okay, so Dr. Macarandeo is an expert in biomedical engineering. Dr. Guo is an expert in wireless communication. And Dr. Santiago is a materials science expert. In Simayodi, my 2 friends are Dr. Panayotova, she's the speaker right after me, and Dr. Lam, my classmate in grad school. And finally, of course, this is our CURM family. Okay, Dr. Panayotova and I are in the middle of this picture, and you can see all of our 9 research kids. Okay, so we have 5 students from CNU and 4 students from NSU. And NSU is an HBCU, CNU is a PWI. So through this collaboration, we were able to make the connection. Okay, so again, based on my research teaching Nexus experience, this is my proposed model. Okay, so I started, my first component was partnership with a non-math expert to expand my knowledge, especially that I am old and I got my PhD many years ago. Secondly is when I created and published those classroom materials based on what I've learned. Then, of course, testing and refining those creations inside the classroom in the war zone. And then finally, that gave me confidence to supervise and inspire students to learn more about mathematics. And of course, a lot of collaboration along the way. Okay, so here in the bottom, I'm not sure if you are seeing the bottom of my screen, but here in the bottom, unlike the models that you have seen in my presentation, I also highlight the different roles that mathematics professors and researchers take on as we go through this experience. So I have here the mathematician, professor, researcher as a learner, as a creator, as a lecturer, facilitator, and as a mentor. Okay. So going back to my question, will conducting research help me become a better mathematics professor? Well, I cannot tell you the numbers yet based on the portfolio of my evaluation because I submitted that a couple of weeks ago, but I can tell you, yes, I think it has helped me a lot because it raised my confidence level as a professor researcher that there is a way for me to still contribute to the mathematics community by publishing a teaching resources. Secondly, yes, I think it helped me become a better mathematics professor because in my classroom now, I am able to deliver contextualized learning to my students so that instead of telling them, oh, you can learn about system of second order differential equations using the pendulum. And they would say, no. But if I tell them that, do you know that a system of second order differential equations is the mathematical framework for the electronic toothbrush, then that keeps them engaged because that sounds interesting to our students right now. And also, it's not in the textbook. Number 3, yes, I think conducting research helped me become a better math professor because now that I've experienced that process of learning about it, researching about it, creating teaching resources, test driving it. So it gave me more confidence to deliver a better classroom experience using inquiry-based pedagogical methods. And finally, I think a good proof that I have improved as a mathematics professor this past 2 years is that students are approaching me to direct their student projects. So these are the references for those 3 research models. For those 3 research teaching Nexus models that I have found thanks to Mr. Google. And these are the names of all my collaborators, at least the ones in the picture. So I guess that's it. I will stop here and I think I am just right on time. Thank you so much for your attention.
Thank you very much, Maila. We have a minute for questions. Would anybody like to, you can unmute yourself, it's a small group, or type in the chat and I can read the question. Give it a minute. The lag time on Zoom needs to be longer than in the room. Otherwise, I have a question. I'm curious about your CURM research group. Are these students working on like semioid projects that you've written or on similar things that you're currently developing? What's their role in this and how has that transpired? That's very interesting.
Yes, very good question. And I forgot to mention that. I have it in my notes, but I forgot to mention that. So regarding CURM, CURM is actually an NSF funded project and it is housed in Occidental College in California. And so with Dr. Panayotova, we developed this, basically a project proposal and they loved it. So they funded us. And so to jumpstart our students' research project, yes, we used our Simayodi products. And so if I go back to this slide here, the Simayodi product on, are you seeing my screen? On the upper left-hand side, which says analyzing an efficient wireless power transmission system. One of our current research projects is doing an expansion of that Simayodi project. So out of our 9 students, we divided them into groups of 3 students. So we have 1 student working on wireless power transmission, another group of students working on population dynamics with real data. So that would be the second Simayodi project on the first row. And then the third KERM research group would be working on the viral therapy. So that should be on the Simayodi product on the left-hand side, second row, about oncolytic viral therapy. Great question, thank you.
That's awesome. How exciting for them.
Yes, it's a great springboard because, like when you're introducing a group of students to research who have not done any research before, then so the first few meetings we were telling them about research and how to use overleaf and how to create a poster and so on and so forth. Then when it's time to do the research, we said, okay, we have prepared this teacher version of the Simayodi. Try to complete the activities that we have laid out here, and that should start your mathematical brains from working on the project that we have given you.
Yeah, very cool. That sounds like an awesome experience to be able to provide.
Yes.
Cool. Other questions? Okay, let's thank Maila one more time. It's quiet applause, but thank you.
Thank you so much. Thank you.
Yeah.